First, we will discuss before the circular queue and double-ended queue. We will enter into that linked lists concept. So first thing is what? So what is that linked list? And how we implement that linked list? There are different types of linked lists, are there? And how we store the information into linked list and all, I'll explain. Different types. The first one is a single linked list, or they can call it as a singly also. Singly linked list, where always information will store in the node format. Node, this is the node. How we create this node means it is like a class. Class, we do like this. Node, inside two things are there. Two things. What are the two things? I'll explain. First one is a data. Second one is a link. It's a connector to the next one. Data and link. Same, this is connected to the next node. Is connected to the next node. Simply, it's a data and is a link. Is the same one? Same one. Here it is connecting that. It's a data and it's a link. Link. This is how we are connecting. This is how we are connecting. First node has some address. Sir, how memory will be allocated? I'll explain. This is the address. This is the address. Just directly I'm writing 1000, 2000 and 3000. You can take that it's a starting node or it is a root node, we can say. It is pointing to this one. By holding this 1000 as an input. By holding that 1000. This is the object. This is the object. To understand, like in Java, you can do like this. Now you will understand, which contains the data as well as a link. It has some address. That address initially into that root variable. Into that root. Then it is pointing to that one. Suppose it has a data is a 10 and 2000 it will store. 20 is a 3000 it will store. Is a 30 and is a no more links, it's a null. Simply null will store. It's a first one. And it is connecting to that second. The address is a 2000 suppose. That address will store here. So is connecting to this node. And where the data is a 20 and that link is, suppose is the next node is a 3000. Because we learn Java in objects format only. That object is only called a node. Data is a 30, but link is null. Link is a null. This one. Now, first of all, how we define the class to create the node. The node has two things. One stores integer value and one stores address directly. That is what integer data. Second one is a node type. This is very, very important. It's a link. It's a class type only. It is a class type only. It holds. Simply to say, it holds node type only. This is the simple way we are creating that single linked list. And what is the root node initially? What is the root node? We create node root equal to null. It is not pointing to any node. It is not pointing to any node simply. How can you create this object? This one you will get confused. How can you create this object? That we know. Simply node. Any node name you can use. N is equals to new node. This is object creation. Memory will allocate to the class only with the new operator. So that we know already. This is what simply to say single linked list. In single linked list, connections always in a forward direction only. There is no backward direction. There is no backward direction. Simply to say, if it is a singly linked list, it has only two. It has only two. Like this. Always it will move only in a forward direction. Only in a forward direction. Suppose if it is an address, 1000, 2000, and is a 3000, and that data is a 10, which holds that next node address, 20, which holds the next node address, it's 30, and it's null. And that root holds, that value is 1000. Root holds that value is 1000. This one. This is called singly linked list, or we can say that single linked list. Second one is a double linked list. Double linked list means what? Every node has previous link as well as a next link also. Every node has two things. It is holding the data, and same, it is holding the data, and same, this one, it is holding the data. It is holding the data. For example, is 1000, and is 2000, and is 3000 considered. The first one is root is okay. Root holding that first node address, but there is no left link. It is null. Is 10. It is pointing to that next node. But next node contains left side is a previous node address. And it is containing that next node. And again, it consists that previous node address. And last link is a null. In single linked list, only last node link is a null. But in double linked list, first node left, last node right, both are null. It's two-way linking. By holding this 3000, it is connected to next node. By holding this 2000, it is connecting to previous node. This is how that links will be. This is how that links will be. Is called double linked list. Is called what? Double linked list. The next one is a circular linked list is there. Circular linked list. Again, is a two things are there. Single circular linked list and double circular linked list also. In single circular linked list, instead of using null value, it holds that starting address is 1,000. Nothing but it is connecting to this one. It is connecting to this one. Simply. In a double linked list, simply it is pointing to the starting node. It is pointing to the starting node. This one, and it is connecting to that last node. For that, we need to write the code anyway. Is a two-way circular linked list. Is a one. Simply, we need to create that single linked list. Next one is a double linked list. Next one is a singly circular linked list. Next one, singly double linked list. Singly double linked list. All these are we are implementing. First, we are starting from the very basic thing we are writing. Very basic thing in coding part. First, creating one class is a node, is a single linked list node. Class I am taking. Class. Okay, now. Two things I already told you. One is holding the data. Second one is a node type because it is linking to the node. Is a node. It is representing that node. It is representing that node. So first, what we are writing. I'm creating one root node. First, simply, in an easy way, I'm explaining the things. In a root node, I'm creating. Root node. What is that node? Root equals to null. It's empty. Equal to null. Then we keep on calling that push and adding to this one. Adding to this one simply. Sir, why you are creating this one? Instead of this, I'm taking one extra class. That class name itself, yeah, I'm taking that. It's a linked list. Itself, I'm taking that linked list. Here only, I'm taking one static variable, is a root type variable. Initial value is a null. Initial value is a null. That is. Then only two methods I am writing. Just two methods. Simply static method. Append method we are writing. Which element you want to append? Append means what? Adding at the end. Second one is a traverse. Nothing but display. Only two things I am writing because I'll explain only these two things. Because if you can understand these two things, remaining everything you can understand easily. Everything you can understand easily. The first thing is the first thing. Here, I'm calling first linked list root is a null. Parallelly, I'm explaining with the code. Root initial value is a null. Initial value is what? Null. Then Here I'm calling directly append method. Append. Okay now. How to call? It's a static method. How to call static method? Using the class name. Linked list dot append is the method. I'm passing that 10 as an input. So the 10 will go and store into this element. Then we need to add. First, what they will do, it will create the object. Node temp is equals to new node. Observe this. Creating object for this node class. Creating object for this node class. Here, that node will be created. Is a node. And it is pointing to some address. Address also here is required now. That address, initially you are collecting into which variable? Temp. Into which variable? Temp. See, temporary variable. Node is ready. They have sent the element now. That element you are adding to which location? Data. Here, you need to add the 10. It's easy. Then simply here you are adding null. This is what data part. This is what link part. So two things. What you have to do the data part. How to access variable? Using dot operator. Element is added. Element is added. Next one, to the link part. Of course, it is by default null only, but explicitly I'm showing. So node is ready, sir. Node is ready. But where to connect that node? Where to connect that node? First, you have to check whether it is the first node or not. If root value equals to null, means what? Yes, it is the first node. Simply that list is empty. List is empty. Then that new node is only the temp. That 1000 simply, that 1000 simply you are adding here. This is the first node. This is the first node is pointing to this one. The point is very, very important. First node creation is very, very easy. Just node temp is equal to new node means empty node will be created. After creating that empty node, we are adding that data and null. Then we are checking whether it is a root node. Root is empty or not. If root has no value, you can directly add that node. Simply that message is what is appended. Appended to list. Appended. For remaining nodes is a else block execute. How it execute else block? Let me explain. Suppose, let me consider already some nodes are there. Just imagine. Already some nodes are there. Just to understand clearly, that's all. Not more than that. Suppose I'm removing this. Is it 2000? And is it 3000? Already this 2000 is stored here, considered. So that it is connecting to this. Is it 20? Is already connecting to this, considered. Is it 3000? Is it 30? Which contains that null. Just consider. Already 3 nodes are there. because else block code I'm writing, else block code. Okay, only else block code I'm writing. In this writing else block code, same again. First, they called append method. Append is the temp is not there because it's a local variable. Once function execution completed, it will be deleted. Now someone called append and send 40. Send 40. First step is what? This statement execute. Node temp equals to new node is a one. It's a new node creation at some location. Suppose it's a 4000 that is initially stored into temp. Is initially stored into temp. Temp to data is element. You have sent 40 now. 40 will store here and null will store here. So node is ready. Now connectivity issue where we have to connect. At last node we have to connect. At which node? At last node we have to connect. Simple. See, in this case, root equal to null. Is it root equal to null? No. Root already 1000. So you have to move from root to that last location. Sir, how many moves are there? There are fixed number of moves? No. We don't know how many nodes are there. We already know this concept. If we know number of iterations, we can go with the for loop. If we don't know number of iterations, we can go with the while loop. We can go with the while loop. So starting from that first, I'm just taking that node, finding the last node, starting with the root. Observe this. Observe this. Starting with the last, but is 1000. Every time we need to check next node is there or not, next node is there or not, next node is there or not. Why? Last to link is not equals to null until link not equal to null. Store that last link into this one. Observe this code. Let me explain. This is the code we are writing. This is the code. How it executes. See. First, last to link. 1000 to link is what? 2000. Na? Yes, sir. 2000 is not equal to null. Then store that 2000 into last. Is it 2000? Next, 2000 to link is what? 3000. Na? Sir, 3000 is not equal to null. Yes, of course. Then store that 3000 into that link. Last is a 3000. Sir, 3000 to link is null. Is a null. Null not equal to null. Sir, condition false. That loop will be terminated because last is already pointing to the last node where you have to connect exactly. Where we have to connect exactly, it is pointing to that node. It is pointing to that node. So using the while loop, we reaches that last node. And very simple, see, here 4000, 4000 means what? It's a temp. It's a 4000 4,000, you need to place to 3,000 to link. Because last node is 3,000. Na? 3,000 to link means this box. In this link box only, you have to place 4,000. 4,000 is already in which location? Temp. Simply last to link is a new one. It's a temp. That is what appended. That is what appended. Only for first iteration means what? If block will execute. First node creation means what? If block will execute. For all the remaining things, it will execute the else block. It will execute the else block. This is the one. Okay. And this is only for printing. How many times? Is any number of times we can execute. I keep on adding that. There is no limitation. We keep on adding like this. 10, 20, 30, 40, 50, 60, 70. So I just want to print. I just want to print that node why it is giving that. First, you need to write that main only. That is a problem here, but no problem. When you are executing that, every time you are adding, see, appended, 7 elements added. No? Simply, finally, you are calling linked list dot traverse, printing that all elements in the list. Just traverse we are printing. How it executes the traverse. List elements I am printing. System.out.println that list elements or list items are. Again, we don't know how many. Again, we don't know how many. Same while loop only we need to repeat. Same while loop. Because how many nodes are there? Starting from the starting node. Take one variable. Temp is equal to starting from the root node. Root is what? 1,000. If it is not null, temp is not equals to null. Not equal to null means what? Is 1,000 null? Is 1,000. 1,000 is not equal to null. Yes, condition is true. Then print the data. Then print the data. See, printing that system.out.println temp2 data is printing. After printing this temp2 data, now 2002 data we need to print. So into that temp, we are taking that link. Next link. 2000. Then 2000 is not equal to null, 20 will print. Next 2000 to link is what? 3000. 3000 not equal to null, 30 will print. Next link is what? 4000. Still 4000 not equal to null, 40 will link. But 4000 to link is null. Final trip is a null will store into the temp. Null not equal to null. See, look at the output is. All the details are printing. All the details are printing. This is the only way of writing that simple linked list code. Simple linked list. But only two operations I have explained. One is appending. Second one is what? Display.